We talk about these slides over here. Can I make it larger? I think I can. Zoom in, maybe a little bit more. That's too much. Okay, zoom 100. It fits. Like this. Better? Nope. Somewhat. Oh, okay. Never mind. Stop messing around. Okay, so we have declaring lists. Notice that lists are very similar to arrays that we're used to either in JavaScript class or in AP Computer Science and Java class. And they're denoted with these square brackets out here. So here I have a list of cheeses, cheddar, Swiss, and Gouda. Oops. So notice that when I copy and paste it, this is a funny thing. With the certain text that I chose for my slides, it doesn't have a difference between like an opening quote and a closing quote. So when I copy and pasted it there, it's thinking that it's all like a closing quote. So be careful if you copy and paste these things. So here's cheeses. That's how we declare it. This is a list of strings, a list of words. You can have different lists. For example, here I have numbers. You can list any kind of numbers, and the elements or the things inside your list are broken up depending on the number of commas you put in between there. So right now, cheeses has 3 things. We say that cheeses is of length 3. Numbers is of length 4. If you want to check the length, there's the len function, numbers. It gives you 4. And if we replace this with cheeses, it gives you 3. So far, so good. That's declaring and initializing lists. And the more confusing idea is down here. Here's a list of lists. You have the word spam. You have the floating point number 2.0. You have 5. And then the 4th element in this list is a list itself. So this is a list inside a list. And that inner list contains the number 10 and 20. That's the harder part that we'll dive into after I'm done talking about you broadly about single list operations. And notice here, empty. Empty list is important too. If you just have brackets, square brackets with nothing inside, that's a legal declaration here, and that's just the empty list. Print out empty. What's inside? Nothing. And as expected, the empty list should have a size of 0 because there's nothing inside. Next up, we talk about a little bit of the in operator. So it's a more complicated example here. This one, we just have 3 things. There's cheddar, Swiss, and Gouda. You notice in, I have no idea what an Edam cheese is, but is it inside my cheeses list or array? You look, you scan the words, and you're looking just on the left-hand side on this shorter cheeses list. Cheddar, Swiss, and Gouda. Does Edam match that at all? Nope. So in gives you false. This example says that, oh, it is not in there. So what about, for example, Gouda in cheeses? Uh-oh, typed it in wrong. Need quotes. I'm looking for the specific word, Gouda, and that's true. This is similar to the, so if you put it, you should recognize it from the for loop. It's that same in keyword. But if you put it with the for, suddenly you're able to move through it. I just wanted to go over that. And this one down here, loaf of milk. These are the interesting conversations we have in the math office. Some of you have an Algebra 2 or teacher of Mr. Knight, and he says, cheeses are just loaves of milk, Mr. Chan. I'm like, fascinating, Mr. Knight. Let me share that with my computer programming kids and see how they react. Loaf of milk. Yep, cheese is loaf of milk. You're welcome. You can thank Mr. Knight. Okay, so more on this. So that's just declaring, okay, we got a list to deal with, and now how do you move through it? Fancy computer science term for moving through a list is called traversing. And then you think, okay, traversing, moving. Probably need a loop of some sort. The for loop is super handy in Python. There's a very subtle difference here in these 2 for loops, and it relates to yesterday's video. So I have for cheese in cheeses, notice the S, and inside I'm going to print cheese. Enter. And my Python, my console on the left-hand side of the screen just prints out cheddar, Swiss, and Gouda. Now, if I go back and I go up, and suddenly I had an S there, how do you think that output changes? Now I have for cheese in cheeses, print cheeses. Yeah, Calvin.
Would it print the array 5 times?
Let's see. I think it does print it a number of times. I don't think not so much 5. So if I extend this a little bit, it should be a bit clearer. Let me expand it this way. So just 3 times. We think back to the very first quiz where you had that turtle function and you had the misleading thing about for color in color array, like a color, right? So Python does this funny thing where if I put in cheeses here, notice that this is your original list, and that's being printed a number of times. How many times? Well, there are 3 things in your cheeses array, so that's why you see the list of those 3 cheeses 3 times. Careful on that difference. One is the thing inside, one is the entire list. Names are very important here in Python. White space is important, and yeah. So for keyword, and let's say now, for example, inside this loop, so I called it cheeses. Oftentimes, maybe we do I. Oops. Okay, funny. Okay, forward. Sometimes we do I, shortcut. You can name, darn it, I did it again. So, shortcut here, I here is very common, like computer science notation. It's just a temporary variable. We called it cheese to make it especially confusing, but if you match it up like this, I in cheeses, print I, it works similarly. It's just a temporary variable and helps you move or traverse through your list. Not so bad. And here's some newer stuff perhaps you haven't seen before. So I have my list here, cheeses, and maybe I want to now combine it with something. So cheeses, let's add that with another kind of cheese. What other cheeses do you know, class? Something I can spell? American. Very good, Thomas. Is that a cheese? Other cheese? Mozzarella. Ooh, that was hard. Did I make it? One more cheese. Feta. Oh gosh. What cheese? So, notice that they combine the list together. You can use the plus operator to like move things together. We'll expand this ever so slightly. Notice that this plus operator, you recognize the first part right here, cheddar, Swiss, Gouda. And there's all the new stuff down here, American, mozzarella, feta, and misspelling of feta. So that's neat. You can also do something like cheeses, your original list times 3, and you get a similar output compared to before. Very subtle difference is now this produces just one list. Notice the square bracket here and the ending one here. This is now a long list of 9 things. And you're repeating your original list of 3 cheeses 3 times. Now if I do times 4, it repeats it 4 times. Okay, shortcuts. Other things that are useful, slicing is a nice operation. By using the colon operator, you can move between different lists, or different parts of your list. So we go back to like the indexes, so those are the addresses or locations of a given list. I'll type this one out. We have A, we have B, we have C, we have D, and E, and F. Let's say we wanted to access maybe certain numbers inside this list. It's kind of like the range function almost. T square bracket, we go from positions 1 up to but not including 3. It prints out B and C. So A is in position 0, B is in position 1, C is in position 2, and then it cuts off right at position 3, so it doesn't include D. Maybe you can do something like 0 to 3. It includes now your first number, or first letter, your first element, A. It goes up to 2, and then still cuts off at D. You go one more over up to position 4, you can include D, but exclude E. Very similar to range. inclusive of the first number, you include it, but then you go exclusive of the second one. You chop it off before you get to position 4. Just like range. Like you do range of like 1 through 7. It gives you a list 1 through 6. Okay, that part is consistent. Now what's neat about this is you don't always need 2 numbers. If you say t square bracket colon up to position 4, it says start at the beginning and go up to position 4. Give me the first 4 things in this new list that's based on the original slicing. Start from the end, stop at position 4. Maybe you can do the opposite too. Start at position 3, have a colon, and this one will take it all the way to the end. So now we see D, E, F from our original list of T. Neat things. You can then shortcut some ways. You have smaller parts of your lists. You can do list-list comparisons. Handy tools. We'll skip over this slide. And then what you need to know is how do you add to a list? Here are 3 functions that somewhat add. You have append, which adds things to the very end. So here it adds the letter D as the 0, 1, 2, 3 in the 3rd position or the 4th number in your list. Extend is very similar to the plus operator. It sticks these 2 lists together. And then sort puts it in some order if you ever need that for your coding bat problems. Other things, if you have add, you must delete. So you have these 3 functions here, pop, del, and remove. Pop and remove are list specific. Del is, I don't see it often with all my interactions with Python, more so pop and remove. So that's how you remove things from there, and I leave that for you to explore if you want to remove certain things from your list from this week's assignment on Coding Bat. Questions, comments? None. Cool. Okay. So the next part of this is I will make a short little program here. This is going to be a pattern. Pattern. Claire, could you help me out? What's the pattern we currently have on the board? The black and blue one on the left-hand side. Pattern D demo code. Okay, so I'm going to save this, and right here on the whiteboard, which I'll type up on the screen, is some a different. It's similar to the starter code you're given on your quiz. I'm typing that in. I'm making my text larger, and let's get something close to what you have to produce for everyone's test revisions. You may solve this a different way, and that's cool. But I wanted to point out something. So this one right here, I comma. It's been pointed out that Trinket does this weird thing between 2 versions of Python, Python 2, the older version, and there's a newer version called Python 3. So be careful when you Google things. It seems like it likes 2 better than 3. And sometimes does this weird blend. I apologize about that. Trinket is a tool we're experimenting with this first semester, and next time we'll fix that problem. So here, notice that if you print I and you have a comma next to it, it removes that new line. What does that mean? So if you delete that comma and you press print, every number is on its own individual line. And that may not be something you want, especially if you're printing out things in a pyramid order. So the comma will help you remove that new line. But also, you want to space things out at a strategic point. This prints out 1 through 6 with a total of 36 numbers. Let's try to get this in a grid format. So after you print out like 1 through 6, when you hit 6, you want to like press enter, make a new line. Then when you hit 6 again, press a new line. Press 6, new line, new line, new line. So the position that corresponds with that is right here. Notice this position inside these nested loops. This is in computer science we say that these 3 lines that I'm highlighting, lines 2, 3, and 4, are inside your J loop. J is the variable that's iterating or traversing. It's the variable being used in this loop. So these are the contents of your J loop. There is only one line that is inside your I loop, and that's line 3. Pay attention to the indenting, but that's just like computer science talk. If you make this change, you should see a grid that's 1 through 6. Pretty neat. Now, to get to the pattern where I have this lower diagonal removed, we have to do and think like, okay, I have to delete certain things, but also I have to move things over. So we notice down here, there is slightly a pattern. When we get down to row 2, suddenly maybe we start slicing things or removing things from our lists, or maybe we don't print out anything. Let's try to fix this first row. So down here, so we're printing I, we're printing I, we're printing I, and let's say when j equals something, 0, 1, I'm now in my second column, j, my outer loop that controls like this row down here. When j equals 1, maybe then we will do a sanity check and print out yay. Darn, that's not what I wanted. So instead of j, yay, like this, print. Okay. Yay is printed out every other one. Why is that? Oh, right. So +1. There we go. So notice my ranges. I start from 1 through 7 because now your indexes and the numbers you wanted to print out are somewhat aligned. What do I mean by that? So for example, quick console, we do range 1 through 7. We want to print 1 through 6. So everything was moved up 1, but that doesn't match up with, for example, range 0 through 7. 0 through 6, 0 through 7, 0 through 6. Notice that this one up here starts at 1, ends at 6. This one starts at 0, ends at 5. That matters. These the range down here, if you start at 0 through 6, it corresponds with the addresses. If you're doing like specific like box grid, I'm at a loss for words. This will be useful if you're working with the indexes. This one will be useful when working with the actual things you want to print out, like the elements of your 2x2 nested list thing. My words. Any ideas, class, on where we should go from here? I correctly targeted this second row. This is 1 plus 1, the second row. Okay, 1 plus 1, I plus 1. 1. Okay, so we get some other numbers. That's not what we wanted. Else, print I, tab, comment, print, else, colon, darn, comma, da-dang. So the quick change was made. So now I added 1 over. Not quite what we wanted just yet, but I hope I give you ideas on how you can shift things over. Last week's lesson was on if statements. You can nest it inside. So this one saying I'm at currently at second row. Notice the use of the comma. Questions, comments? None? Okay.